Hey everybody, and welcome to another lecture with Coding with Roby. And in this lecture, we're going to be going over the Git technology. So let's dive in. Let's start with the first question. What is Git? Git is a free and open source distributed version control system. Git can handle small to large size applications and projects. And Git allows team members to use the same files by distributed branches and environments. Now, if we needed to remember one thing, it is that Git is a version control system for our code. Think of how online documents work in modern day. Typically, when you open a document, there is some type of version control attached, so you can see when something was added to a document and who added the new additional work. This is exactly how Git version control works, but instead of a document, it version controls your code. Let's check out a Git example to really solidify what we're trying to learn with Git. Let's say we have a Python class called math functions, and inside math functions, we have a single function called addition. We can see addition takes in two parameters, A and B, and returns the A and B variables added together. This is a very small and simple class and function that we are using with our Git. However, this version is version 1 of the code. So the first time you have wrote this piece of code within our application is going to be version 1. And remember, this is just a simple Python class and a simple addition function. And now let's enhance this function to now incorporate a subtraction function. Here we have our original class of math functions with our addition functionality. Now the requirement was to create a new function that allows subtraction to our application. So let's add this functionality. We now have our new subtraction function that takes in A and B as the parameters and returns the two parameters subtracted from one another. So now we have our subtraction function and our addition and simple Python class. However, since we added subtraction to this class, we are now on version 2 of this application. And that is because we added a new function, which is a newer version of the code from the original simple application. Okay, now we just got off the phone with our client, and the client wants another function added to this class. They are dying to have multiplication added to the application. So let's add this functionality. Now again, this multiplication function is brand new code. And since we're adding this code to the original application, this makes this entire application now version 3. Now I know this was a goofy example, but what we were able to do was to create a version control system between our application. We started with our version 1 of our code that had just our class and the addition functionality created. We then committed our first change, which included our subtraction functionality, followed by our last commit, which created version 3 of our application along with our multiplication functionality. Now, what is special about having Git in version control is the fact that we can go to any version of our code. We can go back from version 3 to version 2, or we can even go back all the way to version 1. This is all handled within version control and Git. Now, a real example on how version control can benefit you is the fact if you run into a bug on a new feature. Let's pretend you are enhancing our application with a huge new feature that users have been dying to use. Right before you release the feature, bam, you run into a bug that is breaking your entire application. But not just your local environment is broken. You had your entire team add this bug to their local environments as well. If it wasn't for version control, you and your entire team would be stuck, unable to work until this bug was figured out. But thankfully, due to version control and Git, we're able to work on the bug fix while the team reverted this local environment back to a commit before the bug was introduced so they can continue working. Now, another huge pro to Git is that it's distributed, which means everything is spread out. Without Git, we have our class functions, which now include addition, subtraction, multiplication, and division. Bill has the code and is working on a new enhancement to add square root functionality to the application. His teammate, Sarah, is also working on her own new feature to add the power functionality to the application. Currently, without Git, the only way Bill and Sarah can exchange code with one another is for them to send files to each other and continually copy and paste each other's new code and functionalities with hope that nothing will break. As one can see, this is a very dangerous operation, even with version control. But how does one manage multiple files being updated by multiple different people? This is where Git repositories, branches, merges, etc. all within Git take their place. With Git and Git repositories, Bill and Sarah do not need to communicate their new changes and allow Git to handle this process for them. Using Git and Git repos allow the developers to have a peace of mind when developing new features or bug fixes. Git will handle all version control as well, so when developers want to pull or fetch new versions of their code, they can do it without worrying about breaking the application. After we go over the Git basics, how will we be able to use Git within our project? Well, let's take a look at our current to-dos application. We have our todos.py file with a auth.py file, home.html, and some styles.css. Our first commit will to add all of the files to a Git repository. We could add a new commit that will enhance our todos.py file, and we could also do another commit to add an entire new file to our application. This will all get saved into our Git with version control and allows us to deploy our application. We most likely won't be doing commit 2 and 3 since our application is complete, but it is definitely something that you can add to your project to add new features to the to-dos application we just built. With Git, the sky is the limit, because we no longer have to worry about our application breaking due to new features because we can always roll back to an earlier version where the application worked. Remember, Git is a free and open source distributed version control system that allows us to have complete control over our application. Git allows us to have complete version control over our applications, as well as have teammates work on the same files with no fear of overwriting files. Git is becoming a required technology for software developers and engineers. So there is not a better time to learn this technology than now. To recap, Git allows us to track changes for our code, allows us to have a strong version control system, and allows team members to use the same files without needing to sync up every time someone creates a new feature or update. Wow, now I know this is just a bunch of information. Great job. This wraps up the lecture on the Git introduction, and I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, we're going to be installing Git on a Windows PC. So if you're on a Mac OS, feel free to jump to the next video where we go over how to install Git on a Mac OS. But if you have a Windows PC, you're in the right place. So start by jumping on Google or your favorite search engine and typing in Git. The very first response should be the correct website of https://git-scm.com and click the link. This is when we get brought to the Git homepage. So Git is a free and open source distributed version control system designed to handle everything from small to large projects with speed and efficiency. And Git is easy to learn with tiny footprints with lightning fast performance. It has a couple of different areas of information. I'm going to come over here to this little computer where it says the latest source release of 2.34.1, and this is the most recent release as of 2001. So if you are coming in at a later version, that is totally fine, and we can just move forward from there. But for now, let's click Download for Windows. It's going to bring you to this Download for Windows page, where you can click here to get the latest for 64-bit. So we have our 64-bit and 32-bit based on your computer. You're either going to be clicking the 32 or the 64-bit, and I have a 64-bit. So I'm going to say click here to download. And I'm on Google Chrome, so once it got downloaded, it's going to be popping up right here, and I'm just going to click this execution. After I clicked execute, I'm going to get to the GNU General Public License. I'm going to just click next. Here we get to choose our path for the Git installation. I'm going to leave the default path, which is C drive program files Git. Feel free to change this to wherever you want to install Git, but I'm going to leave it at the default location. And then next. Here we can select the components that we want to be installed. We have our Windows Explorer integration with Git Bash and Git GUI. I'm going to uncheck this, as we do not need this for this tutorial, where we're going to be using all of our Git from the command prompt either within our PC or from within our IDE. Here we get to just click a Start Menu folder. I'm going to leave it as the default of Git. Now we get to choose our default editor using Git. Vim or Vim is a editor. While powerful, can be hard to use. Its user interface is unintuitive and its key bindings are awkward. But we're going to leave this as the default, as Git's default editor, because we can still use it within our command prompt. Now adjusting the name of the initial branch in our new repositories. So here we can use let Git decide if we want to use our branch as master, or we can use this override the default branch name for new repositories, where it says it's new and many teams are already renamed their default branches. From common choices are main, trunk, and development. I'm going to leave it as the default for now. Here, adjusting your path environment. How would you like to use Git from the command line? There's a couple different options. I'm going to use it as the recommended, which is Git from the command line and also from third-party softwares. Choosing the SSH executable. So which secure shell client program would you like Git to use? Again, I'm just going to use the bundled OpenSSH. We don't necessarily need to use the external OpenSSH. It's a new feature, but let's go ahead and move forward with the default option. Choosing HTTPS transport backend. Which SSL/TLS library would you like Git to use for the HTTPS connections? Again, just move forward with the default OpenSSL library. Configuring the line ending conversions. How should Git treat line endings in text files? Check out Windows style commit Unix style line endings. Let's move forward with the default option. We don't necessarily need to use checkout as is. Configuring the terminal emulator to use the Git Bash. Which terminal emulator do you want to use for your Git Bash? Again, let's move forward with the default option of use min_tty, the default terminal of MSYS2. Choose the default behavior of Git pull. What should Git pull do by default? And now we're starting to dive more into actions and commands of Git. We want the default to be a fast forward or merge. We don't necessarily want to do a rebase or only ever fast forward. We want to do the fast forward or merge. Choose a credential helper. We're going to use the Git Credential Manager. So when we start using Git, we need to create credentials, and we're going to do this just from the Git Credential Manager. Configuring extra options. So I'm going to leave this enabled, which is the enable file system caching. File system data will be read in bulk and cached in memory for certain operations. I'm going to use this as it provides a significant performance boost. Experimental options, we don't necessarily need to do any of this. We're going to be doing everything from our command prompt or terminal. And now the next option is install. This will take a few seconds to install Git on your computer. And here, completing the Git setup wizard is complete. We can finish to exit setup and launch Git Bash and view release notes. I'm going to click and uncheck both options before clicking finish. And now here, I'm going to open up our command prompt. So I'm going to click our Windows button and then type in command prompt. Once the command prompt opens, I'm going to verify we have Git by typing in Git and then -- version. Here we can see that the Git version of 2.34.1.windows.1 is installed on our machine. This is exactly what we need to be able to move forward and start using Git in our current projects. Now, in the next lecture, we're going to start creating our own folder and actually go over some of the Git commands. But for this lecture of installing Git on a Windows machine, we are complete, and I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, we're going to download Git on a Mac operating system. Now, one good thing about Mac is that it's usually already comes with Git already installed. So there may be nothing you have to do. To check, let's open up our terminal, and inside your terminal, let's type in git -- version. If you come back with a Git version of some kind of number, well, congratulations, you already have Git on your personal Mac OS, and you can actually stop this video and move on to the next one because you already have it installed. If for some reason you do not already have Git and your machine maybe have been erased or wiped or just did not come with Git, that is totally fine. Just head over to our git-scm.com/downloads. This will bring you to the Git download page for any kind of operating system. I'm going to click on Mac OS. And inside Mac OS, we can see there's a couple different ways to install Git. And it's telling us right now the best way to download is using something called Homebrew. And if you click the Homebrew, it'll actually open up this web page of brew.sh. And Homebrew is a package manager for Mac OS. As we all know, it's a little bit harder to download and install and use third-party applications on Mac OSs. So Homebrew allows you to solve all of this. If you do not have Homebrew already installed, just copy this little command, go back into your terminal and paste it. It's going to ask for your password on your Mac machine. It's going to tell you that it's going to install all these scripts. I'm going to press return. And it's going to start downloading and installing. For me, it's more or less going to update it because I already have Homebrew installed on my machine. If you do not have it installed on your machine, this is actually going to install it. So ignore my error because, again, I already have it installed. Now from here, we can type in brew list. If you type in brew list, it's going to show you all of the dependencies that have been downloaded from Homebrew. And you can also see I already have Git, but in case you do not, you're going to want to go back to the Git download package manager and just copy this brew install Git. I'm going to paste this in my terminal. And it is downloading Git. For me, since I already have Git, it's just upgrading Git. So if you do not have Git, it'll just download Git. If you already have, this is also how you update. So it's just updating my Git right now. And sometimes this can take a while. All right, and now after everything is installed, just type in git dash dash version. Once you do that, it'll show you the current version of Git. And if you are seeing a version, that means you have Git. So congratulations, you just installed Homebrew, which is a package manager, and Git on your Mac OS. This wraps up this lecture on setting up Git on your Mac, and I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, we're going to be going over the Git basics. So let's dive in. If we remember correctly, we are starting with version 1, which includes the math functions with the function of addition. After we commit the first version, we will start on the second version. Commit our second version to get our third version, and we'll be able to go back and check out different versions of the same code base. So in this section, we'll be learning about Git basics and how to utilize the Git version control. So what are some of the Git commands that we're going to be going over? Well, let's start by learning git init. Before using Git on a project, we must start by initializing a Git repository on the project and root directory. To be able to do this, we need to go to the root directory of the project and type git init. After initializing a project, all of our files within the project are all currently unstashed, which means we do not have a temporary snapshot of the current updated files. To stash or stage the files, or in other terms allow Git to do a temporary snapshot, we will be using the git add dot command. This will add all files of the application from a non-staged area to a Git staging environment. After we add the files to the Git staging area, we need to commit the files to complete the transaction for version control. So again, we move the files from the Git staging area to a commit. To do this, we need to do the git commit -m command, and the -m stands for message. So within quotation marks, we state the message that we are committing. This is for human understanding. When they look at past commits, they know exactly what that commit was for. Now let's do some version control within our application. When you commit your code, Git will give you a commit number that identifies the commit. When you want to revisit a past commit, we do a git checkout with the commit number. When you do this, we move our version to the commit version we are wanting to check out. We will be also going over git log. When we do a command of git log, Git will show all commits associated with the branch we are on, which will display all the Git commits that we are able to check out along with all messages and authors attached to each commit. So let's take a look at a high-level view of our Git basics project. We will start by creating a new empty directory called Python Git Basics. We will then git init our Python Git Basics to initialize a Git repository. Within our Python Git Basics, we will create a new Python file called main.py, which is able to print hello world. After we add the main.py file and the print code statement, Git will see our file as an unstaged file and code. To stage our code, we need to type in the command of git add dot. This command will stash everything we currently have in the directory. After everything is staged, we will want to commit all of the code. To commit the code to make a version control, we need to do a git commit -m, and within double quotation marks, state what we want to say, and in this example, we're going to say first commit. Again, this is so we understand exactly what the commit is doing, and oftentimes, the first commit of a project is always called first commit. And after this, our first commit will be complete for our project. After our first commit, we will create a second commit right after. We will add new code to our main.py file within our Python Git basics. The new code will print 2 + 2. Now, of course, this code doesn't really do too much, but for our first try with Git, we're trying to make the code extremely easy to understand. Now that we added new code, our code is unstaged. Again, let's do a git add dot to stash our code changes. And now that our code is staged, we need to commit our changes. We can do this by doing a git commit -m with our message being added addition functionality. After this, our second commit is now complete. So now within our app's version control, we now have 2 different commits. Now that we have commits added to our code, let's view our commits. We can view all of the commits by typing git log. After typing git log, we can see all of our commits with information present with each one. Each commit will come with a commit ID, author, and the message we added during the commit. We can see in this example that there are 2 commits, the latest commit being added addition functionality, with our very first commit just simply saying first commit. Since the last thing we committed was the added addition function, that is currently where the head of our code is. To do version control, we can type git checkout AA, BB, CC, DD, EE, and then 1 through 7, just so we can switch back to the first commit. After we do this command, our head, which is what we can see, is going to switch to that commit, which will remove everything we added for the added addition functionality. Now I know this was a bunch of information for, the first round of us learning the Git basics, but let's go see this in practice where it may make way more sense. This wraps up this lecture, and I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, we're going to go over the very basics of Git. So let's start by creating a new directory. On my Windows machine, I'm going to right click and say new folder. And I'm going to name this Python Git Basics. And now I'm going to open up PyCharm and open up this folder. I'm going to click open. And in desktop, I'm going to click Python Git Basics. And these interpretators you can turn off for now. And what we can see here is we started with a file automatically, and I'm going to remove all of this. And I'm just going to type in print hello world. And I'm going to right click and run this application just to make sure everything is working correctly. So what we currently have is we have a new folder of Python Git Basics with one file inside, which is main.py. Let's hop into our terminal. And while we're inside Python Git Basics, we have to use a command to make sure Git is embedded into this folder and directory. So the first thing we need to type is git init. Once you type in git init, we initialized an empty Git repository, in our C drive leading up to our Python Git Basics directory. And now let's type in git status. When we type in git status, we can see that we're on our master branch. We currently have no commits yet. We have nothing tracked within our stage environment, which is our .idea, which is just going to be the IDE and some cache for PyCharm, and our new main.py file. Nothing added to the commit, but untracked files present, and we can use git add to track these changes. So the first thing I'm going to say is git add dot. And what git add dot means, this means add everything that is untracked and add it to our staging directory. When I click enter, we can see that we get a warning LF will be replaced by CRLF in our idea leading up to our project default and our project settings. We can ignore this for now. Let's now type in git status again. Now we can see that when we retype git status, we're getting all of this new information of git ignore and some other information within our .idea, but we're also getting our new file of main.py. And these changes are now to be committed and are sitting within our staging environment. Once we add new directories and files to our staging environment, we have to commit these changes. To now be able to commit these changes, we have to say git commit -m with a sentence or a definition of what we're about to commit. And here we can initially see that we get our commit with our -m first commit for our project. We get a commit which is going to have a bunch of different information. If this is your very first time using Git may be asking you to tell them who they are and add some configurations. We can add our Git username and user email configurations by typing in git config -- global user.email with your email. And we can do the exact same thing, but this time we may need to pass in a name. Now, if it didn't ask for this, that means you already have your name committed onto your Git. And I already do, so we can ignore that for now, but you may need to add it just in case. So now if we redo git status, we can see that PyCharm added something else. So let's do git.add again. And let's commit it as a PyCharm change. And now for the last time, let's do a git status again. And we can see that on our master branch, there's nothing new to commit and we're working on a clean branch. Let's add in one more statement under hello world. And I'm just going to say 2 + 2, just so we have a new change. If we run this application, we're going to see we get hello world and 4. So inside our terminal, if we say git status, we can see that our main.py was modified. And we have a few options we can do. We're on our branch master. Our changes that are not staged for this commit is our main.py file. And we can reverse it by saying git restore our main.py file. Or we can update our main.py file by using the add. Again, I'm going to add our file. But this time, instead of using dot, which means all files, I'm going to specifically type in this main.py file. And now if we say git status, we can see that our main.py file is now in our staged environment. And if I say git commit -m added an addition functionality, we're going to see that our application is going to push in this commit. And now once again, let's say git status. Again, there's nothing in our commit, but this time I'm going to type in git log. When we type in git log, we can see our last 3 commits, which is our first commit for the project, our PyCharm change commit, and then our added additional functionality, or added addition functionality, which is going to be our head and our master. We'll go over what this means in a second, but as we can see, we have 3 different commits all within inside here. Now, something that we can do is this is our commit ID. If we copy this ID and we exit out of this git log by pressing Q, we can say git checkout that ID. And we can see that there's a whole bunch. You are now in a detached head state, and we are able to experiment here, but turn off this advice for settings on our config, but our head, which is our page, is now on that new commit of PyCharm change. Now watch what happens. When we click our main.py file, our addition functionality went away, and that's because we went back a commit before we added the addition functionality. If we go back into our git log, which is going to show all of our reversions, our head is on this second commit, which is version 2 of the application. And now if we want to go back to our old commit, we can say git checkout -sign. And this more or less goes back to what we had previously in our git. So if we click this, we can see that our previous head position was this, but now we switch back to our branch of master. So if I click here, we can see that now in our main.py file, we get our addition functionality back. Also, if we say git log, we can see that we have our first commit, our PyCharm change, and then our added addition functionality is now our head and our master. If I press Q to close this, and I say git status, we now get on branch master, nothing to commit, working on a tree that is clean. And congratulations, we just went over the absolute basics for Git. So Git init, being able to create new commits and being able to check out old commits and switch back to our master, and all the fun stuff that Git brings us, and the power of Git. So we have now reversion control in our application. This wraps up this lecture on the Git basics, and I will see you in the next video. Hey everybody, and welcome to another lecture with Coding with Roby. And in this lecture, we're going to be going over Git branches. So let's dive in. What is a Git branch? Well, a Git branch is simply a pointer to take a snapshot of a change. Branches can be merged into other branches. So a branch, again, is just a pointer of a data change. Branches help with isolation of features in development, and branches help with linear development. Branches are extremely needed and important when dealing with Git, and we will want to isolate branches with just about every new feature to our application. So what are some of the Git commands and examples we'll be using when dealing with branches? The first command is a git branch. When doing a git branch command, we create a new isolated branch where we will be doing our development. After creating a branch, using the command git branch, we successfully created a new branch. However, we need to check out the new branch so we are able to use it. To do this, we need to say git checkout branch followed by the branch name. A newer way of checking out a branch is using git switch. Git switch can be used only with Git versions of 2.23 or higher, and is now the modern way of changing branches. We'll be going over git switch just in case you want to try it out. Now, what will we have to do to our current application? Currently, our entire application is sitting on the master branch. The first thing we need to do is to create a new branch by typing git branch multiplication branch. This will create a new branch for us, and now we need to check out the branch by typing git checkout multiplication branch. With this, we now swapped out our master branch with our new multiplication branch. We have our master branch and we have our multiplication branch. We will check out our multiplication branch, and while within our multiplication branch, we will add code to our multiplication functionality. We will then add and commit our change to the multiplication branch. After the commit, we will need to merge the multiplication branch to our master branch. To start the next development video, we start by renaming our main.py file to math functions and adding the appropriate functions of addition and subtraction. We then want to git commit this change into our master branch. After this, we are going to be creating our new branch called multiplication branch and then checking out this new branch. Within this new branch, we are going to make a new multiplication function, git add the new multiplication function and commit this function using the messages adding multiplication function. And once the branch is all committed, we are going to merge the multiplication branch back into the master branch. Now I know I just went over quite a bit regarding git branches, but let's go ahead and see this in a practical example in our next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, we're going to go over branches and being able to merge branches and how we can use branches to really create version control and added features to applications. So let's dive in. Alright, so the first thing we're going to do is to rename main.py into mathfunctions.py. So I'm going to right click, refactor, rename to mathfunctions.py. Now if we do git status, we can see that we have renamed our main.py file to mathfunctions.py. And now let's add some new functionality to math.functions. And let's erase this print hello world and print 2 plus 2. And the first thing we're going to do is create a function called addition. So def addition, and we're going to pass in a and b as the parameters, and we're just going to return a plus b. And then let's create another function called subtraction. So def subtraction, we're going to pass in a and b as the parameters, and then we're going to return a minus b. Let's now call two print functions that are going to print addition and subtraction, and we're going to pass in 10 and 5. So print addition 10 and 5 as the parameters, and then print subtraction of 10 and 5 also as the parameters. And it does look like I have a spelling error in subtraction. There should not be another S, so I'm just going to remove the second S to make it subtraction in the function, which then will cause an error in the print, so I also need to make it subtraction there. Alright, so let's go to our terminal and say git add dot, which will add all of these changes to our stashed environment. So now when we say git status, we can say we have our new file of math functions, and there's going to be changes inside the math functions. So let's commit these changes by saying git commit -m, and the message I'm going to say is rename and new addition and subtraction functions. So here we can see that there was a couple file changes where we created a new mode of math functions and we deleted our old main.py. And if we say git branch, we can see master. And then git status, we're on a clean branch. So I'm just going to do git branch one more time to just again verify that we're on our master branch. Now let's create a new branch, which is going to be in isolation of our master branch. We can see that we are in our master branch and we want to create a new branch, which is going to add our new functionality of multiplication. So I'm going to say git branch multiplication. And now if we say git branch, we should see two different branches, our master and our multiplication branch. We can now switch over to our multiplication branch by saying git checkout multiplication branch. Now if we say git branch, we can see that we're no longer in our master branch, we're in our multiplication branch. However, if we say git log, we can see that at this commit, which is the rename and new addition and subtraction functions, we both are at the head using our multiplication branch and our master branch. To make this a little bit more clear, while we're in our multiplication branch, let's add new multiplication functionality. So I'm going to say def multiplication, a and b as the parameters, and then return a times b. And now let's print multiplication of 10 and 5. If we run this application, we can verify the multiplication functionality works. Now let's jump back to our terminal and let's do git status. So we can see that we're on the branch of multiplication branch. We don't have anything staged for the commit, but the only thing that's changed is modifying the math functions to now include the multiplication definition or function and the print. So let's say git add dot, and then git commit adding multiplication function. Now let's do git status to make sure there's nothing in our stage environment. And now let's do git log to look at all of our changes within our log. If we open up our log, we can see adding multiplication function is the head, which we're currently looking at, for the multiplication branch. So if we go back to our terminal and click Q, we can switch back to our master branch. And when we switch to our master branch, we're going to see all of this functionality disappear that we just added. However, we want to add the multiplication branch into our master branch. And we can do this by merging. So we can say git merge multiplication branch. And this time, we're going to see a fast forward of our math functions.py. And now within our master's branch, we can see that our multiplication branch is now added in. Now, as you saw, we are using git checkout a lot of the times, and you can use git switch if we're using a version of git which is new enough. So instead of saying git checkout multiplication branch, we can say git switch. And now we switch to our multiplication branch. And the reason they added switch was because checkout can be used for commits within the specific branch, and it's also the same verbiage to get new branches. So they added switch and a newer version to try and differentiate the two a little bit. And to be able to switch back to the last branch you were in without actually having to type in anything, you can say just git checkout -sign. And one last functionality, if we remember we had to create a new branch and then check out that branch, you can do this all in one code by saying git switch -c new branch. This will create the new branch and check it out for you. And lastly, let's switch back to our master branch. Let's do git branch to verify we're on the master branch. And now we can delete branches that are already merged into our master branch. Let's first do git log to verify that our head is our master, our new branch, and our multiplication branch. And now, instead, let's type in git branch -d with our branch name of multiplication branch. And now let's do git branch. And we can see we have our master and our new branch. And while on master, let's also delete the new branch. And then a git branch to just show our master branch at the end. So what we were able to accomplish here is we were able to create a new branch, multiplication branch, where we added a new functionality of multiplication. And then we were able to merge that multiplication branch into our master branch, so there was no changes happening. And you typically create new branches when you want to add new enhancements or new functionality to an application. This wraps up how to handle merges, branches, and commits when dealing with multiple branches. And I will see you in the next video. Hey everybody, and welcome to another lecture with Coding with Roby. And in this lecture, we're going to be going over GitHub. You may be wondering, what is GitHub? Well, GitHub is a repository hosting service. This in essence means a place where we can put our code online. If we remember from our Git slides, Git allows developers to be able to communicate with a hosting service that deals with all of the Git hosting, so developers no longer need to communicate with one another when exchanging code. GitHub also comes with a user-friendly interface. Most of the time, other than when dealing with Git commands, you'll be working directly with the GitHub website interface, which is extremely easy to use when there is many things that it can do. GitHub also has a large development platform. This just means a lot of people use it. This is great when it comes to documentation or just wanting to share your code with others or read and see other people's code. So how does Git differ from GitHub? Well, Git is the technology that we'll be using. Git is a free and open source distributed version control system. GitHub, on the other hand, is a Git repository hosting service that works with Git. So in essence, Git and GitHub need each other. They work together to be able to deliver and give an amazing experience to you as the developer. Let's check out another diagram of how Git and GitHub work together. We have our original application that we enabled with Git, so we have our version control. Well, we don't want to be the only computer with this code base. We want the code to be stored safely on the cloud using GitHub. Now that my code is on GitHub, I don't want to worry about my code being wiped on my computer and Bill and Sarah not being able to access my code and add code as they wish. However, everything will be secure because Git is still happening and adding version control when they push their code changes back to GitHub for me to access. And since Git is distributed, as long as they never push their code back to the GitHub server, it will never affect my code. What we can see from this example is that all Git data is saved on the cloud. Individuals can access version control and team merges. Now, just for reference, there are other options for using an online hosting platform, which includes GitLab, Bitbucket, and a few others. But for this course, we're going to be going over primarily GitHub. This wraps up the GitHub overview, and I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this short lecture, we're going to be going over remote Git commands. What are some of the remote Git commands we're going to be going over? The first command we're going to be using is the git remote add origin. This command more or less allows you to add a remote repository. The git remote command lets you create, view, and delete connections that are remote. Origin is pointing back to the cloned repository. Git push is used to upload local repository content to a remote repository. Pushing, in essence, is the way we transfer commits and data from your local environment to the remote environment. This allows all of your local commits to now be pushed to our remote repository, which in essence allows all of our Git data to be on GitHub. Now, I know this lecture was super short. I just wanted to go over the remote Git commands before we dive into the practice. So this wraps up this lecture, and I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, we're going to create a GitHub account and then push our repository from our code base to our GitHub repository. So this is an awesome video where this is our first step to being able to deploy our application. So the first thing you need to do is head over to github.com. And when you get here, you'll know because you get this little globe that you can grab and move around where you can see different commits going on all over the world. It's a super cool animation that you can mess with. But once you're here, where the world builds software, you can click sign in or sign up. Sign in if you already have an account, sign up if you need to make one. Once you click sign up, it's going to walk you through a pretty cool process on creating your first GitHub repository. But I already have an account, so I'm just going to sign in and I'm going to return back to the video once I log in. Alright, now once you make a GitHub account or you sign in, you're going to go to your repositories. So once you click repositories, it's going to show you all of your repositories that you have. You can make private or public repositories. From here, I'm going to click new repository, and this is how we're going to push our code base to a new remote repository. Here we get to call our repository whatever we want. I'm going to use FastAPI. You can do the same thing. The name is going to be your username / your repository name. So you can copy my names if you want because it's going to be your username / your repository name. So I'm just going to name my repository FastAPI. And I'm going to make it public, which means anybody can see this. If you do not want anybody to see yours, you can say private. And you know what, I'm actually going to change it to private. So we have a public and private. Public, anybody can see your repositories. Private can only be you. And here in the initialize this repository, you can say with a readme, with a git ignore, which means with our git, we can ignore certain files that will not be added to our git. We don't need to add anything for now. Just click create repository. And boom, we have our username / FastAPI repository made. And here it's telling us how to create new stuff for our application. Now this first command, echo #FastAPI, this will create a readme.md file. But if you're following along in the application, I already have a readme file. If you do not in your application, feel free to type that in your terminal. Next, it's going to say add the README, but really we want to add our entire application after we git init it. So let's initialize our git first. I'm going to start by saying git init in our parent directory of our FastAPI application. Now that everything is initialized, I'm going to say git status. And here we can see everything that's about to get added to our Git, so our remote repository. Now, one thing I do not want added in here is this FastAPI env. That is because there's a ton of files in our FastAPI environment. And this FastAPI env is used only for our local. When we deploy this application, that operating system, or wherever we're going to be deploying it, which is Heroku for this application, is going to download everything and create its own environment. So this is specific to our local environment. So we don't necessarily want to add this to our remote repository. To do this in PyCharm, we can just right click it, head down to where it says Git, and then we can say add to Git ignore, and then add to Git ignore. And like I said, our git ignore is something that we can add, which is going to be a file to our application, which says we do not want this item to be added to our Git. So it's going to say, do you want to create a new file? I'm just going to say yes, create this file and add it to our repository. So now inside our git ignore, we have our FastAPI env, which is this entire folder which holds a ton of files. Now let's do a git status. And now we can see our .idea, which is our cache for our PyCharm, more PyCharm cache, to-dos DB, template static routers. We got all of the main files for our application. Now I'm going to say git add all. And if we say git status again, we can see all of our files for our application have been staged. Now if we go back to GitHub after adding our README, but we really added everything, we want to git commit our first change. So I'm going to follow this exactly. So I'm going to say git commit -m first commit. And then I'm going to say git branch -m main. This is renaming our master branch to main. And then we need to say git remote add origin, which is going to add a new origin to our path to our remote branch or our remote repository. And now for this last one, git push. I'm going to add this to our application for now, but I'm not going to press enter. And the reason being is GitHub is going to require a password for our application, but not your actual password to be able to log into your application or log into your username. It's a different kind of password. So what it actually wants you to do is to create a token. So I'm going to hover over my account and go to settings. I'm going to scroll down until you see developer settings. And then I'm going to click on personal access tokens. And I'm going to say generate a new token. I'm going to name this token FastAPI. I'm going to make sure this token lasts for 30 days. And you can change it to 7 days, 60 days, 90 days. I'm actually going to make it 7 days. And I'm going to give it full rights to my entire username. What this is saying is if you have this access token, you can pretty much do whatever you want. This is your token, and make sure you save this token to a safe spot. And then after this, I'm going to go back into our PyCharm and click git push -u origin main. And you're going to get the first time authentication failed. But if you do it again, you're going to get a pop-up of a GitHub add-on. Head over to the token, and now paste that token in that you just copied, and click sign in. Once you do that, your validation is going to be complete, and you just pushed your change to the main branch. So now if you go back into your GitHub, and you head over to your repositories, you can see that I now have a new FastAPI repository on GitHub that was added 17 seconds ago. And if you click on this FastAPI, we're going to see our commit with all of our changes. So there we have it. You have your Git remote branch or your remote repository on GitHub. That is fantastic. Awesome job. This wraps up this lecture on getting our application onto a remote branch or a remote repository on GitHub. And I will see you in the next video.